Let's have a closer look into Internet application. I already mentioned that the application interacts with a TCP/IP protocol stack via a protocol that is located on the application layer. And then this protocol hands over the data to the transport layer, for example, to the TCP protocol, and TCP protocol hands over data to Internet protocol. In this way, communication is organized. We have discussed this already in detail. TCP was one of the two important transport protocol. You remember, transmission control protocols, the TCP. This was connection oriented. This was reliable. So a large number of such Internet application use the TCP protocol as a transport protocol. For example, the SMTP protocol, the simple mail transfer protocol, which allows to send email. The HTTP protocol, which is used to transport web documents. The hypertext transfer protocol, they make use of the TCP protocol. The RPC, the remote procedure call protocol, is using TCP protocol. The MIME extension, the multipurpose internet mail extension, the file transfer protocol, the Telnet protocol, the domain name service, they all make use. These are all Internet application, and they all make use of the TCP protocol. So these are the application located on the application layer, and they hand over their data in their special format to the transport protocol, and then TCP take care for the transport, the reliable transport over the Internet. Here is, you can see this on one view. This is a TCP protocol on the transport layer, and these are the different protocols on the application layer. You see here in the picture, for example, the SMTP protocol as well as the HTTP protocol. Both make use of the MIME protocol. Same is true here with the Telnet. That is also, FTP can also use the Telnet to hand over data to the TCP protocol. Now you remember also that beside of the TCP protocol, we have another much simpler protocol on the transport layer, and this was the UDP protocol, the user datagram protocol. It was a very simple protocol. It was connectionless. It was unreliable, and a lot of Internet services also make use of the UDP protocol, either in parallel to the TCP protocol or instead of the TCP protocol. For example, the trivial file transfer protocol that's working with the UDP hands over data that needs to be transported over the Internet to the UDP protocol. Domain name service also makes use of UDP. The SNMP protocol, the simple network management protocol, which is used to administrate, to manage the administration of networks. Of course, these are protocols which are needed in error cases. And if you imagine there is an erroneous network, and before you can use this tool, you have to establish a TCP connection, is too much overhead. So such type of protocols, they cooperate with the UDP protocol, the boot protocol, the dynamic host configuration protocol, the real-time transfer protocol, the remote procedure call, the network file system, the routing information protocol. A few of them we already have discussed when we discussed about protocols on the other layers of the TCP/IP protocol stack. So here is a picture of the Internet service that make use of the UDP transport protocol. So here we have, as I MP protocol, DHP. We also see the NFS protocol makes as well use of XDR as of RPC. So some of the protocols, for example, domain name service, makes use of TCP as well of UDP protocols. So this gives you an orientation about family. On the one side, it's about families and services on the internet application layer. On the other side, about how this application protocols make use of the internet. A few more words about client-server principle. Internet applications are the main actors that communicate with each other about the internet. We already said that they do this in the client-server paradigm. So we have on the one side the client process, typically on the side of the user, and then on the server process is running, and then the client, this is the active component, client initiates establishment, initiates a communication with the server. It makes a request for a special service or special resource and sends this over the internet to the server. And on the other side, the server is a passive component. It's waiting. And as soon as a request comes from a client, the server tries to send a reply or a response. Typically, it sends back the requested data. In some cases, if find out that the client is not authorized to request the data, it sends back a failure message, not authorized. If the server is not able to provide this resource, then it sends also the back. So here, the client, the initiator of the communication, sends a request, and the server sends a reply back to the client. In this is a model to make it easy to design software which realize this interaction, which realizes communication. So a server, of course, is able not only to answer a request from one single client. Servers are able to serve for many clients, and servers are also able to provide several services. So here is a picture which shows we have a client, we have a server, and let's assume the user wants to send an HTTP request to the server, wants to see a website. Then this HTTP protocol, this HTTP request has to be transported over the internet, so it has to take over to the transport layer, to the TCP protocol. TCP protocol establishes a connection to the server by making use of the internet protocols and the concrete technologies, the concrete protocols of the local networks. Then internet this request is sent in form of a TCP package, encapsulated by an IP package, encapsulated by local area network packages, sent over the internet, and here on server side, the server, after the message is handed over to the several layers, the server see, okay, this was a request. The server, let's assume, provides several services beside of HTTP, also Telnet, also FTP, RTSP, and the server recognizes, oh, this message sent by the client is an HTTP request, and then he answers with the requested resource. So the question is how the application can interact, can hand over data to the protocol, to the internet protocol software. And we already discussed, when we discussed about TCP, the endpoints of the communication, and that are the so-called sockets. So as well on the sender side, as well on the receiver side, such communication endpoints with some resources are needed, such sockets are needed, and then the communication runs between these sockets. So the connection between the two systems, and in order to maintain that these communication endpoints are uniquely identifiable, such sockets are needed. So here is a picture. We have the sender, we have the receiver, we have the interconnecting internet, and for the communication there is on both sides, on sender sides as well on the receiver sides, sockets. And the sockets provide storage space that may be used for providing for communication buffers. The address of the socket, the way to identify such sockets is the socket address consisting of an IP address followed by the port number. Remember when we discussed protocols, the TCP protocol, we discussed in detail this mechanism. So in this way, when sender and receiver use internet for exchanging data, they are able to address the endpoints of the communication. And since the speed, the processing speed on both sides and the communication speed are not absolutely synchronous, by means of such buffers, by means of provided storage resources, the communicated data can be stored even if processing needs a while of this data. The sockets define a bidirectional interface for the interprocess communication. And they followed in the design of such sockets followed the BSD Unix way to address and to deal with such endpoints, in that case of interprocess communication. Now this model is used also for communication over the internet. So a socket is made up from a source and the destination address, of course on the sender side, on the receiver side, and on the port, the source port or the destination port. And then it's necessary when describing and naming, addressing such sockets, it's also important to mention the network protocol that's used. In this way, programs can access, the applications can access a socket, similar like a file can be accessed. So operations are available to read something, to write something, to flush something. For example, applications that wants to get communicated a message to a receiver can write this information into the output buffer, and then the Internet Protocol serves to transmit the data. And vice versa, if there are data transported over the internet and are located in the input buffer, by means of the read information, this information can taken out from the input buffer and hand over to the operating system. So in this way, this socket mechanism in the internet is comparable with the Unix sockets for local interprocess communication. Now we have a communication between processes. In the internet we have communication between processes located in different locations.